Hello children, welcome to another interesting session of digital classes physical sciences. I hope you are all doing well. So in the last sessions we discussed about matter around us and in how many states the matter is going to exist. We have solid state, liquid state and gaseous state of matter. And solids, different kind of materials in our daily life. We can see a stone is a solid, a duster is a solid. We have clarity on the solids clearly. But whereas liquids and gases combinedly known as fluids. So today we are going to learn what are the exclusive properties of these fluids, the mechanical properties which are going to be exhibited by the fluids. So combinedly liquids and gases are known as fluids. So in our session today we are going to discuss detailedly what is a fluid and what are the different properties of the fluid. Are you ready children? Yes, let us start our session. Observe carefully. All of you know this is floating on water. All of you know what is the name of that thing, right? Next, a huge ship, again it is also floating, and you can see an iceberg in an ocean. So some of the iceberg is floating and most of the iceberg is inside the water, and you can see some pebbles which are inside the water. Are they floating? Think once. Are they floating or they sink? So dear children, let us have a little fun with an activity. So observation of different objects when dropped in different liquids. So see children, you can see a container is there with some water, a fork is dropped, a painting brush and some different objects are there in water, and you can easily guess which object is floating in water and which object is not floating in water. So this is with a common sense that what we are experiencing in our day-to-day life, you can guess which objects are floating and which objects are not floating in water. Dear students, observe this activity carefully. Take a tumbler and pour some water and kerosene. So what you can observe? The kerosene is it floating on the top of the water? Which is on the top surface and which is on the bottom surface? You can see clearly. Now let us drop some objects. A Nile, and we are dropping some objects gradually, and a piece of pencil. Oh, it is floating, and you have to observe carefully which objects are floating and which objects are not floating and in which liquid they are floating. So we are dropping different, a matchstick. So this is a very funny activity, even you can do in a simple way, an eraser. So these are all the objects, a pen cap, you can see clearly. So this is also floating, but you have to observe carefully. Oh, this object is not floating, it is floating. So these are all the objects, some objects a piece of paper. So some objects are floating in kerosene, some objects are floating in water, and some objects are sunk in water. So this is the activity that you can categorize, that which objects are floating in water, which objects are floating in kerosene, and which objects are not floating in water and kerosene. From this activity, what did you observe? Did kerosene float above the water? And which objects float in kerosene? You can answer all these questions after the activity. And which objects sink in kerosene but float on water? So you can answer all these questions after the clear observation of the activity that what we did in the previous slide. Now dear children, so what you can observe here? This is a book and it occupied some space. So book occupies space. So every object is going to occupy some space. So every matter occupies some space around it, and this space occupied by an object is called volume. So that already you know, every matter or every substance is going to occupy some space around it, and the space occupied by an object is known as volume. Is it right? Now what is the unit, SI unit for volume? So in lower classes also we learned the unit for volume is cubic meter or meter cube in SI system and centimeter cube in CGS system. Right children? And all of you know matter is made up of molecules. Already we learned it in the previous topics. So matter is made up of molecules. So let us see. See, in this picture you can see a book, and how the molecules are going to arrange in case of a book is you can visualize. So this is the arrangement of the molecules, how they are going to be oriented in case of a solid substance, here that is a book. Now let us try to think which is heavier. So in the picture you can see an iron weight and cotton. So iron weight of 1 kilogram and cotton, if you take and try to answer the question which is heavier, you can answer easily, yes, iron weight is heavier. So how can you say it is heavier, and what is the scientific meaning of heavier and lighter? So you can see an iron weight and a cotton. You can see clearly the structure of the molecules in case of iron weight. So the molecules are closely packed. Dear children, you can see this is the orientation of the molecules which are going to be closely packed in case of iron weight. And whereas in case of cotton, so the molecules are loosely packed. So the molecules are loosely packed in case of cotton, whereas the molecules are closely packed in case of iron weight. So what is the significance that which we can observe from this activity? Again you can see this is iron and this is the molecules orientation, and in case of cotton this is the orientation. So what is the speciality in this diagram is both are in same space. You can see a cube. This is a cube and this is a same volume of a cube. Volume is same. That means they are same size. This is a cube and this is another cube of same size, but iron more molecules are there, cotton less molecules are there because of closely packed reason and loosely packed reason. So number of molecules are more, so more mass will be there for iron. That is obvious, right? More molecules means more mass. Mass means what? Matter contained in the body. So here the molecules are loosely packed, because of that reason the cotton is going to have less mass for the same volume. That is very important. Volume is same box. In same box we took iron and cotton. Iron molecules are closely packed, so iron is going to have more mass and cotton is going to have less mass for a same volume. So iron has more mass per unit volume. So for a given volume iron is going to have more mass. So with that activity now we are going to define what is the reason, that is the density of the material. So ready children, we are going to define the very important concept. The very important concept is density. Okay. So what is the definition of the density? So first you try to understand the definition of the density. So mass per unit volume is density. So density is mass upon volume. and density is represented with a symbol rho. Rho is equals to mass by volume. So rho indicates density and m is for mass and v volume. So the mathematical formula for density is mass upon volume, and definition is mass per unit volume is density, and density rho is equals to mass by volume. So very important formula for the density. Then what is the significance of the previous activity? So you can see, children, here we have three different kind of liquids. So this liquid is on the bottom and this liquid is in the middle and this is on the top of the two liquids. So what is the reason? Yes, the reason because the three different liquids are going to have different densities. So the density is the reason for all the three liquids to occupy different positions. Understood? So now we are going to prove the density of iron is more than cotton from the previous activity. So as we know, this is an iron weight and a cotton, and iron has more mass per unit volume than cotton. Already we proved it. So density of iron is more than cotton. So density of iron is more than cotton. How can you say iron has more mass? You can see iron has more mass per unit volume. If you take, this is the iron weight and same volume of cotton, if you take same volume, so definitely iron weight is going to have more mass. So density of iron is more than cotton. Now what are the units of densities in SI system? So to understand any physical quantity we need the unit. Understanding completely the physical quantity is the unit itself. So mass usually measured in kilogram in SI system and volume is measured in meter cube, and density formula is mass by volume. So mass is kilogram and volume is meter cube. So the unit for density is kilogram per meter cube. So the unit for density in SI system is kilogram per meter cube. Understood, children? So rho is used to denote the density. Rho is equals to mass by volume. Again I am giving the formula because this is very important formula. So mass is kilogram, volume is density, so unit is kilogram per meter cube. Next, what are the densities units in CGS system? Again, mass is measured in grams in CGS system and volume is measured in centimeter cube. So density is mass by volume again, and gram per centimeter cube is the unit for density in CGS system. Right, children? So this is a very important unit for density in CGS system. Now let us think what is the relation between the SI system of density and CGS system of density. Let us try to do it. Okay. So how many gram per centimeter cubes is equal to 1 kilogram per meter cube? So this is an interesting question for you. Right, children? Now again we will think which is heavier. Now let us see, this is an iron cube and this is a wooden cube. You can see clearly both are having same volume. One is made up of iron and the other one is made up of wood. So everybody can say iron is more heavier and wood is less heavier, that means lighter. So in the language of science, how can you say it? Heavy and light in the language of science. So in the language of science, the denser object is heavy. That is the meaning. So the one which is going to have more density, that is said to be a heavy object, and the one which is having less density is said to be a lighter object. In case of heavy and light, in the language of science, the denser object is heavy and the less denser object is said to be light. Now comparing the densities. So how can you compare the densities of the different objects? So dear children, you can see we have three different boxes. This is an interesting thing. So we have three different identical boxes and we filled one with water and one with petrol and one with milk. That means all the three are going to have same volume because they are filled with same volume. Is it right? In same boxes we are pouring water, petrol and milk. So all the three are going to have the same volume. So think children, which is going to have more density? How can you say? Is it petrol? Is it water or milk? Which is going to have more density? So this is an interesting question, right? So this is the way of thinking about the density concept. All the three are going to occupy same volume. Then we have to think which is going to have more density. That means we have to keep all the three boxes one by one on the weighing machine. So which is going to have more mass, that is going to have more density, because all the three are going to have the same volume. So this is understanding the concept of comparing the densities. Now how can you say the relative density of an object? Relative density of an object. Relative means comparison. So how we can compare the density of one object with another object, or the density of the object with the density of water, because water is going to have the density which is standard 1 gram per centimeter cube. So the density of water is 1 gram per centimeter cube. So we can, if you want to find the density of other objects, we have to compare it with the density of water. Now density of object by density of water. So very, very important formula children. Relative density of an object means density of object by density of water. Okay, so density of object by density of water is the relative density of the object. So now let us see one important lab activity. So very, very important lab activity that you can understand the concept of relative density. So what is the aim of this experiment? What is the aim of this lab activity? Finding the relative density of a solid. So how to find the relative density of a solid? We are going to see with an activity. So what are the materials required for this? Overflow vessel. You can see children, this is an overflow vessel which is the required material, and 50 milliliter measuring cylinder, electronic weighing machine and some required weights. So these are the materials required. Now see children, you observe carefully. So this is a weighing machine and some weights are there. You can see clearly. So what is the weight here? 99 grams. So the weighing machine is indicating 99 grams. You can see children. So the weight of the weighing machine after a weight is placed is 99 grams. Now take overflow jar. It is showing 0 reading. We adjusted the reading to 0. Now you insert the object that which we want to find the relative density. See children, so I am inserting the object. Now some water overflown into the jar. Now the reading is 14 grams. We can see children. So now the reading is 14 grams. Earlier 0. With empty glass the reading is 0. Now with some water came out of the overflown jar after inserting the weight is 14 grams. So earlier only it is 0, now it is 14, right children. Now how to find the relative density? See children, so first what is the formula for the relative density is weight of the object by weight of the water equal to the volume of the object. So the formula for the relative density of a solid is weight of the object. So what is the weight of the object? That already we found, right? And weight of the water equal to the volume of the object. As it is the ratio of two weights, so numerator is weight of the object and denominator is also weight. So two weights are going to cancel. So there are no units for relative density. So the units for relative density is no units. Now tabular form, that what we conducted for the experiment. So for the relative density of the solid. So, see children, first we took iron weight. So, in the experiment, in that lab activity, first we took iron weight. So, what is the weight of that iron weight? 99 grams. You can see weight of the object, that is iron weight is 99 grams. Now, weight of the water displaced by the object. When that iron object is immersed in water, some water came out of the overflown jar and already that weight is 14 grams. So, now what is the formula for relative density of the object? 99 by 14. Why? The formula is, the relative density is weight of the object by weight of the displaced liquid. So, 99 by 14, it will be 7.07. Okay. So, 7.07, this is the relative density. Density means 7.07 gram per centimeter cube, but relative density means no units for relative density. So, relative density is 7.07. Understood children? So, with that lab activity, we found the relative density of that iron weight is 7.07. Right children? Then how to find the relative density of the liquid? So, dear children, in the previous lab activity, we found how to find the relative density of a solid substance. So, now we are going to do another activity, that how to find the relative density of a liquid. Ready children? So, see this. So, relative density of the weight. So, weight of the liquid by weight of the same volume of water. So, relative density of the liquid is weight of the liquid by weight of the same volume of water. This is the formula for the relative density of the liquid. So, 99 by 14, it is 7.07. This is the relative density of the iron weight, that what we found in the previous activity. So, now relative density of liquids. So, the formula for the relative density of the liquid, how to find the relative density of the liquid is, so weight of the liquid by weight of the same volume of water. So, we have to weigh the liquid and weight of the same volume of water. So, you can understand this another lab activity. So, lab activity 2. So, to find the relative density of the different liquids, this is an easy experiment. So, first you take an electronic weighing machine and reading with empty measuring cylinder. So, you can see children, we have an empty measuring cylinder. So, what is the weight of the empty measuring cylinder? It is 0. Now, fill it with water. You can observe, fill it with water. Now, what is the weight? 20 grams, right? Now, reading with milk. Now, fill the same with milk. Earlier it filled with water, now it is filled with milk. Now, what is the reading with milk? It is 22. So, you can see children, first empty cylinder the reading is 0, and with water the reading is 20. We have water here, and with milk the reading is 22. And now, so how to find the relative density of the milk? So, by substituting in that formula. So, weight of the milk by weight of the same volume of water. Simply you substitute those values in this formula. So, weight of the milk is 22 by weight of the same volume of water is 20. So, you will get 1.1. So, with that activity we can say that relative density of milk is 1.1. Now, take same container and fill it with kerosene now. So, what is the reading? You can observe children, with kerosene the reading is 16. So, now how to find the relative density of kerosene? So, same formula, weight of the kerosene by weight of the same volume of water. So, kerosene weight is 16, water is 20. So, what is the relative density of kerosene? It is 0.8. Now, take another liquid. Now, fill it with coconut oil. So, this is the container with coconut oil. Now, you can see the weight. What is the weight? The weight is 19. Now substitute the values in the formula. So weight of the coconut oil by weight of the same volume of water. Water already we found in the beginning itself. So weight with coconut oil is 19 and with water is 20, that is 0.95. So with this data we can categorize the different liquids are going to have different densities. Now you can see in the tabular form. For milk we have 22 and 20, that is 1.1 is the relative density. For coconut oil 19 and 20, so 19 by 20 0.95. For kerosene 16 20, that is 0.8. With this we can understand whose density is more. Think children. So density of milk is 1.1 relative density, coconut oil 0.95, kerosene is lighter. So the density of kerosene is least among the three. Now dear children, so what have we learnt in this session? So let us try to recap what we have learnt in this session. So what is density? Mass by volume, and units of density and relative density. Units of density and relative density also we learned. Density mass by volume, that is kilogram per meter cube, and relative density no units. So finding the relative density of solids and liquids with lab activities and comparing the densities of different liquids, and try to improve your learning by answering these questions. Do all the objects that sink in water sink in kerosene? Give the reason. Then how can you find the relative density of a liquid? Write the units of relative density. And why do some objects float on the water and some sink? Now, dear children, so this is the introduction of density and the concept of relative density for the different liquids and solids. I hope you understood well, and let us try to answer the questions given, and we will meet with another wonderful session in the coming classes. Right? Thank you.
రైతు మిత్ర వ్యవసాయం ప్రత్యేక ప్రసార కార్యక్రమం